Based on electronegative differences, which of the following compounds is the least ionic? And then we have basically like a multiple choice. Would it be potassium fluoride, KF, NaCl? Why is this my favorite compound, I guess, right? Why is NaCl so special? If you've watched the video, the deep dive on this topic on our website, check it out, glazersguide.com. Link is in the description. You'll know why. Let me know. Let me know in the comments. Would it be NaCl? Would it be LiCl, lithium chloride, or cesium fluoride? Well, thank you for this. They gave us a big electronegativity chart here with their values. We just have to find out the electronegativity differences. And just know that electronegativity differences, literally all you got to do is just subtract the electronegativities. Okay, so let's just pull up what each electronegativity value would be, and then we'll find the difference. We'll subtract the difference, and then we'll go from there. So let's see. Potassium is 0.8. Any other potassiums? No. Fluorine I see here is a big number, 0.4, or actually 4.0. Sodium is 0.9. And we got a couple of chlorines here. Chlorine all the way down here is 3.0. And I see that I have 3.0 as well. I also have another fluorine. So I'm going to plug that one in. Fluorine down here, 4.0. Lithium is 1.0. And cesium is 0.7. Okay. Now, when you're finding out the electronegativity differences, just know that this is the absolute value. When you do your subtraction, just know that you're always going to get a positive value at the end of the day. When we talk about our differences, we just make them all positive. Because electronegativity, it's a relative term. It's not really quantifiable. You can't really figure it out as far as, you could figure it out quantifiably, aka with numbers, as you would with energy values or something like that. And these only exist when there is a bond. So, when we just subtract these numbers, the easiest way to do this is to just take the higher number mentally and subtract it from the lower number. Or, big number minus small number, right? Always take the big number first minus the small number. So in my mind, I'm just going to take 4.0 and minus it. And maybe I'll just make this a little bit. Yep. 4.0 minus 0.8. We got 3.2 left over. And I'm going to keep doing that for all of these. So I'm going to take my big number, 3 minus 0.9. I have 2.1. 3 minus 1.0 is 2.0, and then 4 minus 0.4 is 3.6. Now we want to find out which one is the least ionic. I'm going to put it down here that if you are classified as being an ionic bond, your electronegativity difference depends on your teacher or professor. Now, if you're going by a scale, the general rule is that it just has to be greater than, so I guess it would be this. It just has to be greater than 1.8. So on a scale, you basically just have to be greater than 1.8 when you find out your difference. Some professors or teachers, they just simplify this 1.8 and they say, well, you could, score it to 2. But I would do 1.8 because that's a little bit more exact. 1.8, that's an easy number to memorize. 1.8. 18, right? 18. What a fun year. Seems so long ago. But anyway, so if we are classified as ionic, we just have to be greater than 1.8, which all these differences are greater than that value. And just know that the greater and greater and greater and greater the number you are, the more ionic. So if we want to find out the least ionic, we want to be the closest to that 1.8 value. So, whichever one of these is the closest to 1.8. Which one do you think? Yeah, it's definitely the 2.0. It's only 0.2 away from 1.8, so this one would be the least ionic. The most ionic would be the farthest one away, just to put it into context. And ionic bonding is just a bonding type in which electrons are transferred, not shared. So this would have like the least transfer of electrons. This one is going to happen so quick, so fast, the transfer is almost complete. But as far as answering the question, LiCl is your answer, because we wanted to know the least ionic. And that's it. That's how we do it. This is how we do it. That I hope deserves a like, right? If you haven't liked the video, please like the video, subscribe to the channel if you want to help us out. Thank you so much. How you guys doing? Let me know in the comments. I love talking to you guys in my spare time. And if you want more practice problems like this, head on over to our website at glazersguide.com, where I'll be there, my brother will be there, and we're there for you every step of the way with practice problems just like this one, deep dive videos into topics, and it's like a big hangout session. So, get your favorite drink, coffee, tea, mine is coffee, get some, snacks, and let's get ready to rumble. I hope you're doing well out there, and I'll talk to you soon. All right, bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.